Hello guys, welcome back to Cosmic Background News, another edition of Cosmic Lessons, and today we're doing stars. We're going to be going over how stars form, how do we classify stars, some facts about our sun, and finally how stars die. Alright, let's start off with a brief description of those pinpoints of light in the sky we call stars. Stars are everywhere. There are hundreds of billions of stars in the night sky. Stars come in many different luminosities, temperatures, and of course sizes. Stars can also be navigation points like Polaris, the North Star, which provided sailors a way to know which way is north. Stars also form patterns in the sky, in which we call constellations. Stars are what provide light and signs to our world. Stars are everywhere in our universe. Over here you can see a Hubble image of some stars. How do stars form? Well, actually, stars form from the death of other stars. When a star dies, it releases the hydrogen needed for other stars to form. This collection of gas is called a planetary nebula. It's kind of like the other star is donating for the birth of new stars. In this picture, you can see a planetary nebula in which all the hydrogen gas is around the dead star. Right there is the dead star, and it has shed off all of its gas around it, and in this area, new stars will form. Here are the steps for a star to form. First, a large cloud of cold hydrogen gas could be disturbed by a large event like a supernova. Once the cloud is awake, the forces of gravity and outward pressure from the other stars begin having a tug-of-war battle. Fortunately, gravity wins the battle and the cloud contracts under the influence of gravity. After that, protostars form and the process of fusion begins. Nuclear fusion is when at the protostar's core, it begins fusing hydrogen into helium. 4 elements of hydrogen equals 1 element of helium. This process makes the star's core hotter and eventually the star ignites, blowing off all the dust around it. Astronomers classify stars based on the star's luminosity, spectral type, color, temperature, and evolutionary stage. To put this all on a chart, astronomers use a Hertzsprung-Russell diagram, also called an HR diagram. As you can see by the chart, the main sequence stars are right around here, while the higher luminosity stars and bigger stars are near the top, and the lower luminosity stars and smaller stars are near the bottom. What class is our sun? Well, you already figured it out from the HR diagram. Our sun is classified as a main sequence star, which means that it is in the middle of its lifetime. Our star, the sun, is about 4.6 billion years old, about halfway through its lifetime of its expected lifetime of 10 billion years. The spectral class of our sun is G2V, or you can just say G. How does a star die? Well, it depends upon the size of the star. There are 2 paths. The first is for similar stars with a similar size to that of our sun. The second path is for stars that are supermassive, or bigger than our sun. Here's the first path. For sun-like stars. After about 5 billion years, our sun will swell to a very large size, even enough to swallow Mercury, Venus, and maybe even Earth. The sun is now a red giant star. A few million years later, and the red giant will begin to shed off some of its outer layers, consisting of hydrogen and other light gases. The red giant will continue to shed off more layers, with each layer consisting of heavier and heavier elements as it gets closer to its core. Then all that's left is a white dwarf, and around it a beautiful planetary nebula where new stars will form. The second path is for supermassive stars. This time, after billions of years, the star will swell to up to red supergiants, which are much, much larger than the red giant our sun will become. Unlike our sun, when the red supergiants run out of hydrogen to fuel into helium, the star begins to fuse heavier and heavier elements, finally ending up with iron, which is the heaviest element it can fuse. When that happens, the star begins to become unstable, which then results in a supernova. The supernova is a big bang, and all the matter from the star is flung out into space. The star that is remaining is either turned into a very dense neutron star, or what we all know as a black hole. Here's a quick recap on what we've learned. We have learned how stars form involving the steps it takes. We have also learned how stars are classified using the HR diagram. We have also learned what class our sun is and how it stacks up against the other stars. And finally, we have learned how stars die, including the paths 2 stars can take. Thanks for watching, and don't forget to subscribe.